Hi, I'm Chet Haas, an engineer on the Android team at Google. I do a bunch of work on animations, and I've done some DevBytes in the past on ListView animations, and I got a request to show how you might animate adding and removing items from a ListView. So recently I did a talk with Romain Guy on animations at Google I/O. You might want to check that out since it has some of the content and related content as well. And one of the demos that I showed was removing items from the list view, exactly what people wanted. I've tuned the code a little bit to make it a little more general purpose, and we're going to show a bit more about how it actually works today. So the idea with list view removals is that you're deleting an item there. Maybe you want to swipe it out. In the demo that I have, you swipe these items out, and then the swipe itself is animated, and after the item is removed from the list view collapses the gap around that item, and views move in from the top or the bottom wherever they need to. And all of this is seamless to the user. It's kind of the effect and the feel that you want with a list view, but it may not be particularly obvious how to do so. So let's see how this actually works today. Now, one important point that I should point out, if you look closely at the code in the Google I/O version of this demo, you'll see that I was using a property called transient state, which was added in Jelly Bean. I've actually removed that. It's used implicitly under the hood when you use a view property animator, but I'm not using it explicitly in the demo code anymore because I actually found a more general purpose way of doing this animation, so it's a little more applicable to different releases as well. So let's see how it works. So if we take a look at the code, one important point, and this is right at the heart of why I don't need transient state anymore, is that I'm using a stable array adapter. This is a subclass of array adapter that I created to return true for has stable IDs. This is a key element because I'm no longer animating the views directly, getting information directly from the views, and then making sure that those views all stay on the screen at the same time. That's dependent upon the Jelly Bean capability of transient state. Instead, I am dependent upon the underlying array adapter to have stable IDs so that I can count on those items actually being the same as changes in the array adapter happen. So I do that by returning true there, and when I get item ID, I actually get unique IDs as I process the array. And then the only other custom thing that happens in this array adapter is I set an on-touch listener because every item in the view, as it's created, I want it to know where to go for its touch events because I'm going to customize that with some swiping behavior, which we'll see very soon. So if we go back to our activity class, here's that touch listener that we were just talking about. So the idea here is that I want to note when the user clicks down, and I want to note when they swipe left to right because I want to first detect when it's gone far enough that we're actually in a swiping motion now. So I'm going to start animating that as they move their finger. So then I want to position the view, and I want to also set the alpha of the view to make it disappear more the closer to the edge of the screen that it gets. And then when they actually let go of that item, I want to determine whether to snap the item back or to animate it all the way off. I should point out that in the widgets that we actually ship, we use velocity tracking, which is a better way to do this in general. I'm using a simple heuristic of how far have you moved instead, which works for the purposes of the demo. I think a more full version of this effect would actually use velocity tracking instead, so that as you lift it off your finger, as you're swiping to the right, then the item would actually animate at the same speed that it was just moving, which is a nicer effect. Nevertheless, simple approach here, and also simple to change using velocity instead. So when the user presses down, if there's another item pressing, I'm not handling multi-touch clicks here. We're just making a simple demo here, so we return false. We're not going to handle this event. Otherwise, we set the value, say, okay, we're now tracking things, and we're going to note the initial version of the initial location that they pressed down in so that we know how far to move the item in initial move events. When there is a subsequent move event here, we get the current location of that. And then we know how far the user has moved the item in general, and then we also know whether to detect for swipe slop, which is basically how far they moved. Have they moved past the point where, yes, we think it's not just an error, but we should actually start swiping this thing out. So you'll see a little jump at the beginning as we detect that it's not just noise, but they're actually moving it far enough for us to start swiping it away. We tell the list view to disallow intercept touch events because I don't want the list view doing its own thing with scrolling up and down at the same time as I'm trying to swipe items back and forth. So when you call this method and set it to true, then until the final up event from the touch event processor, then the items have full control over here. The list view will not get in your way. And then we tell the background container to show the background. We'll get into this a little bit later. This is the detail about what exactly we're going to show behind the item as it's swiped away. So if we're actually swiping this thing, then we're going to set the translation X. So we're going to move this item back and forth according to how far the user's finger has moved. And we're going to set the alpha. We basically want it to be the inverse of how far away it is from wherever they started. So the closer they get to the edge of the screen, one way or the other, the more translucent it's going to be. The idea being that it's going to fade out all the way by the time it gets off the screen. And then finally, when the user lifts up, if they were swiping this thing, then we can find out how far they swiped it, whether they're going off the screen to the left, off the screen to the right, and then we can set the duration based on that. We're going to set the duration based on how far they have left to go to the edge of the screen, whether it's popping back into place or actually popping all the way off the screen. We're going to set enabled false on the list view. This prevents the user from doing something silly like actually scrolling and flinging the list view at the same time as we're animating all the views into place. Makes things look a little bit more consistent and reasonable on the screen. And then we're going to set that enabled to true when we're actually all done with the animation. There's two animations that are going to kick in here. The first is that we're going to animate the swipe out or the swipe back. And then if it was a swipe out, then we're going to run a following animation, which is going to animate the closure of the gap that that item created when it was removed from the list. So we're going to set the duration according to that duration that we calculated before. We're going to animate alpha. This is using a view property animator, which was API that came in 3.1, Honeycomb 3.1. And we're also going to animate translation X to its end value, either back all the way on the screen or all the way off the screen. And then we're going to run an end action. Now, this is API that came in Jelly Bean, so if you're writing for Jelly Bean and later, that's fine. If you're writing for APIs for runtimes that are earlier than Jelly Bean, you don't have to use an end action here. Instead, you can set up a listener on the view property animator, and it's just a little bit more code, but it's effectively the same thing. When the end of the animation happens, we're going to run this code. So the swipe has happened. Now we actually want to animate the removal, removing the gap in the list view. So if we're actually removing the item, if it was swiped off, then we're going to animate removal here. Otherwise, we're all done and we're just going to restore the values that we need. So animate removal is down here. Now this is the different approach from the one that we took at Google I/O. The talk in Google I/O talked about let's track where the views are here and let's set transient state on all those views to make sure that they don't get recycled when layout occurs. We don't care about that anymore because we're using item IDs instead. So what's happening is the following. For all children that are currently in the list view, and this is before layout runs, so there's no data set change yet. The list is just the way that it was at the time that the user was swiping it. We're going to track where these things are. So we want to know where the views are, but we're going to store that information about position in a hash map that's keyed off of the item ID instead of the view itself. Right? So for every view, we're going to say, where are you now? We're going to get the top value, child.getTop. We're going to find out where it is in its container, and we're going to store that information with the key of the item ID that's associated with that view before a layout runs and recycle happens and everything gets all confused in the list view. But we don't care because we've got the information we need, item ID associated with position of the view at the time. Then we're actually going to remove the item, and we're going to remove it from the adapter. That automatically does a notify dataset change. And then we use a trick that's common to a lot of my animation demos, which is we set an on pre-draw listener. So what's happened is we've removed the item. This is going to force a layout to happen on the list view. Views are probably going to be recycled. We're going to chuck them out of the list view. We're going to figure out where items need to go. Then we're going to repopulate views. And who knows what view is where, but we don't care because we have stable IDs. We're good to go. Layout is going to happen, and then our pre-draw listener is going to be called. And this is the important point. It's going to be called before draws happen. Right? So layout runs, then it calls our on pre-draw listener, and then we can do whatever we want. And what we want to do is set up an animation to animate views from where they were in the previous view, in the previous frame, into where we want them to be now that layout has run and the list view has finalized all the content for these views that changed. So the on pre-draw callback gets called here. We remove the listener because we don't care about it after this one frame. Then we come in here and walk through all current children of the list view. Right? So this is everything after layout ran, everything got recycled, shuffled around. For every one of those, we're going to say, okay, where are you now? Give me your current top position. And if the position of that same ID, so I'm also tracking the current ID of this view, and I know what the ID used to be for that content before layout ran. And if we have a non-null value for start top, that means that this view used to be somewhere else in the container, and we're going to run an animation to animate that change in values. So if the if the top position before layout for this content is different than the top position for that item after layout, then we want to run the animation. So we're going to set an initial translation Y value to basically run it back to wherever it started from, and then we're going to animate to translation Y of 0. So we're basically just going to animate it into place. If this is the first time it's running, then we want to, with the first animation, go ahead and restore some values when we're done. Kind of a tedious detail there. If there is no starting position for that particular content item, then that means that this view is just moving onto the screen, either from the bottom or the top. So we calculate an initial position to start from, and there's a little bit of repeated code there. Don't worry about that. And then we come in here and we again set the initial translation Y value to that delta, and we animate it. The animation code is exactly what we saw before. The only difference is calculating the initial position for an item that was previously off the screen, didn't exist in the list view container before. And then when we're all done, we clear the top map, which is where we were storing these values of item IDs associated with the top positions. The only other, that's all the animation code here. The only other thing that's interesting here is the background container. So there's kind of a graphics optimization here, where if we are constantly drawing a background behind a list view where all of the items are opaque, then that means we're basically getting overdraw. We're drawing an entire background, and then we're drawing all the items on top of that background, which is kind of a wasted effort. If you really care about animation, if you really care about performance, and you notice that you're getting bottlenecked in some situations, then one way that you can work around this is to set a null background on that container so that we're not going to draw anything behind it. Well, that's a problem if you're swiping out and you see into the nothingness that's behind the list view. So what we do is when we start doing the swipe, we tell the background container to show the background. That sets up some initial values here so that we know where to draw this item background. And then we override onDraw and say, okay, well, if we're drawing this thing, then we'll go ahead and translate to the open area, and we'll draw our shadowed background. And our shadowed background is seen here. This is called from the constructors, and we simply load in this resource. This is a 9 patch that I defined. It's very simple. It's basically shadow on top, shadow on bottom, and then an area in the middle that gets stretched. And the net effect, which you can see in the demo, is that we have a little bit of shadow and a little bit of shadow on top and a little bit of shadow on bottom, and then this gray area in the middle. So it makes it look like all of the items in the list view are sort of popped out from this virtual background that we have there. Another item to mention is sometimes when you're animating list views, if you have dividers in the list view and you're sort of playing with things like we are here, like animating the translation properties, you may know notice the dividers aren't necessarily getting drawn correctly. So I disabled dividers. So if you take a look at the layout for application, we have list view, divider of null, and a divider height of 0. So the list view itself is not drawing dividers, and instead I've defined the text view to actually use a divider. So it's using a background, which I defined, which is basically all opaque white with an opaque line at the bottom of it. And that gives me my own divider that gets animated along with these items as they're moving around the list view. So again, this is List view removal animations. It's the ability to animate all the changes. You could do a very similar thing with adding. I just only took care of the one direction today. But it's doing it in a way that is usable on all property animation APIs all the way back to when View Property Animator came in, which is 3.1. In fact, you could use Object Animator for everything and take it all the way back to 3.0. And if you want a little teaser, in a future demo, we'll see how we can use a very similar technique and actually run this thing on Gingerbread as well. So check out the talk at Google I/O that we did on animation called A Moving Experience, and download the code and play with it and make your list views more dynamic. Thanks.